Assalamualaikum and a very good day. I am Nurul Wahyu binti Yusuf from University Technology Petronas who will be presenting on the implementation of team-based project to correlate the theoretical and practical concept and principles of chemical engineering. Principles of chemical engineering or material and energy balance is one of the core courses in the chemical engineering degree that offered to the first year student. These courses focuses on the application of mathematics, science and engineering fundamentals. However, the basic core discipline in principles of chemical engineering is normally difficult to comprehend because it involves theoretical concepts, equations, and many variables. The course delivery is also usually conducted in a basic mode. In addition, a new generation of students, millennials typically, prefer interactive learning approaches. Due to these attributes, the students are uninterested, unmotivated in class, and difficult to understand theoretical concepts as implemented in the real phenomena. This is associated with the poor performance demonstrated by the students in their summative assessment including tests and final examinations. In fact, feedback from the industry that complains inability of graduates to apply the knowledge clearly exhibit the lack of theory-practice implementation in engineering education. Therefore, these drawbacks drive the motivation to change the teaching approach for first-year engineering courses. The complement between theoretical and practical work has been identified as a reinforcing strategy that can be used to enhance the efficiency and knowledge of the students. Therefore, the team-based project is embedded in traditional studies to simulate the links between theoretical and practical concepts for this course. The implementation of this invention involves the integration of teaching philosophies to design a new curriculum including 5Is inquiry-based learning approach with particular highlight on the exploration, and this approach which involves higher level of Bloom's taxonomy in which creating element. This invention involves 81 students. Firstly, they need to form a team comprises of 4 or 5 students. After that, they need to understand and identify the problem as they are required to design their own setup by using recycled materials and complete problems covering a range of materials and at the same time practice teamwork and professional skills. In this work, they need to employ conservation laws of mass, energy and momentum. They use their creativity and engineering judgment to construct a system with the limited resources they had in their dormitories or homes. Live demonstration and report submission is conducted before peer assessment and survey. During demonstration, students were asked to explain their project, the working principles and the prototype safety features. They were given 15 minutes for the presentation and demonstration and another 5 minutes for the following question and answer session. The students are required to submit the report on their practical project, which comprised of the schematic diagram of the prototype, discussion on the principle of chemical engineering principle use, calculation, assumption, costing and hazard analysis on the prototype design and operation. And these are the examples of the reports. Based on the surveys conducted, more than 80% of the students agreed that the implementation of team-based practical project increased their understanding on the fundamentals and concept in material and energy balance. The implemented approaches was identified as a good way in understanding the contents of the disciplines, motivates them to learn further about the principles of chemical engineering and real application, help them to prepare for test and final examination, and the class is fun and interesting. Based on the exam results, the percentage of students that can score for this subject increases. The increment can be related to the influence of the innovation work that the students experience throughout their learning in the subject. So, the usefulness of this invention is to emphasize new approach and pedagogy in teaching and learning of principles of chemical engineering or materials and energy balance course. It also triggers the learning excitement, ignite creativity, cultivate students' understanding, and equip them with practical skills as well as boost student competencies. For the commercialization potential, the innovation has the potential to be implemented at all higher learning institutions to create a practical team-based project that stimulates link between theoretical and practical concepts in the course. The innovation is consistent with the demand of the employers who require graduates to have fundamental theory knowledge and technical or practical skills. The innovation is aligned with the direction of the Malaysia Education System, the Malaysia Education Blueprint 2015 to 2025 in boosting graduates' marketability. For recognitions, we have secured 2 gold medals, one from TLRF 2020 and another one from IUCEL 2022. In addition, we have published our invention in TLRF proceedings as well as IUCEL proceedings. That's all from my side. Thank you.